So we continue with Python. So in this session, we'll be dealing with the way we create a variable. See the variable creation. So when you say variable, it is the location, okay, which holds or which refers to some other object, as we discussed, right? So it can basically contain a reference to an object. Actually, in Python, exactly to be precise, it can contain a reference to an object. Okay, so when we frame the variables, what are the rules we follow? How do we frame the rules? Okay, for example, I'll just show you the demonstration. See, the variable can start with letters, underscores, or one underscore, whatever it is, and it can have mix of digits and uppercase, lowercase letters, right? And of course, we can have various combinations of letters, uppercase, lowercase, digits, underscore, everything. Okay, and words normally they are separated. When you have multi-word variable, they should be separated by underscore. For example, let me just show you the demonstration. See, I can just say rate of interest. Rate of interest is equal to 8.5. So you can see here. So this is how we put underscore between the words. Okay, so this is the rule which we have to follow, right? And of course, the variable names are case sensitive. So if I say rate of interest, and see, look at this, rate of interest, so I can just 8.5, and I can have one more variable with caps. Look at this. Okay, and I can say this is completely different. Look at this. Now this is rate of interest. I can just say 7.8. Okay, so if I say rate of interest, I would like to display this. So this is 7.8, but this rate of interest will be, okay, you can see. So you see two. So look at this. I'll just show you the below cell. I'll just say B, then I'll say Control V, Control Enter. So you can see. So this rate of interest is different from this rate of interest. Even though the spelling is same, but their case is different. Right? So variable names, okay, are case sensitive in Python. Okay, fine. So that is the thing which we need to know. And apart from that, we have built-in objects from library. Okay, when I say built-in objects, for example, you see, you can say I'll just create a variable here. Okay, even this is a built-in object, 56.8. It's a built-in object. Okay, if I say type of, you can see a float. Okay, so float is the type. So it's a built-in class actually. So 56 point is the object of type float. Okay, fine. So in the same way I can have string. I can just go. I'll just go down. See, my name is equal to sethuraman. Okay, so if I say type of my name, you can see str. Str means string. So str is the class name. Okay, the generic name is string, but str is the actual Python class name. So sethuraman, okay, is an object of str class. So this is what you have to remember. And my name is a variable which refers to that sethuraman, that string. Fine, that that object actually, that object. Okay, fine. So these are some important things we need to remember. And of course, object from library means we'll be creating some objects from built-in library. Okay, so that and all we will see in our future things. And object created from user, even our own, we can write our own classes. Okay, and we can create objects for those classes. Okay, fine. That is all we will do. Now, if you look at the integer type, the integer type can be represented using various forms actually. You see, basic integer is a base 10 integer. I'll just show you output here. You can see here. Okay, I'll just say Control Z. I'll just say escape B. So it will insert one more cell here. Now what I'll do, I'll just see what I'll do. I'll just go here. The basic integer. So if I say num is equal to 190. So if I say num, I get 190. But this number can be stored with other base also. See when you say 190, it is base 10. It's a decimal number. If I want to store a hexadecimal number, then what I should do? I should say 0 0 0, O can be small or capital. I just say 10 for example, 1 0. It's not 10, it is 1 0. So if I say num, you can just see we will get 8 as a value. Why? Because see octal, basically in octal, this is called octal actually. It's not hexadecimal, it is octal. 0 O means octal. Okay, 1 0 means, see in octal, the digit starts from 0 to 7, then it restarts. Okay, so it's see the lower order bit, it starts again at 0, higher order bit is increased by 1, so it becomes 1 0. So 0 to 7, the next digit will be 1 0. Okay, so you just see here, but we get 8 here. That's equivalent decimal integer is 8. Okay, see 0 to 7, okay, is our octal digits. The next digit will be, in decimal it is 8, but in octal it cannot be represented because octal digits are made up of only 0 to 7. See, as hexadecimal is made up of 0 to 9, sorry, not hexadecimal, decimal is made up of 0 to 9, octal is made up of 0 to 7 only. So you cannot use 8 in octal. 8 and above you cannot use it. So it should be only 0 to 7. Once it reaches 7, again it starts at 0. So the higher order bit changes to 1. So from 0 it increases to 1. So it starts from 1 0 to 1 7. Then again it becomes 2 0. Okay, it's like that. So this is called octal. Then if I say hexadecimal, I'll just say see same number, num is equal to, I'll just say 0 x. X can be small or caps. I'll just say ff. You can see here ff. I'll put a single f. The single f means it's equivalent to 0 to 15 actually, 0 to 15. Okay, 0 to 9 of course. Then 10 will be represented by A in hexadecimal. Okay, 11 will be B. Okay, 12 will be C. 13 will be D. 14 will be E. And 15 will be F. So you can see the number output, you can just see. When you say 0x means you want to represent in hexadecimal F. So you can just see 15. Okay, 15 is the number equivalent. So for F, equivalent decimal is 15. Right? So see, when you say an integer, it is not that you can represent only with base 10. You can represent with base 8. Base 8 means octal. For that 0 O, then 1 to 7 any digits, combination of digits. Then if you say hexadecimal, it should be 0x. Okay, where the digits they starts at 0, then goes up to F. So 0 to 9, A, B, C, D, like that it goes. Okay, fine. So this is hexadecimal. Then apart from that, we can have binary representation. So if I say num is equal to 0b. 0b means binary. So if you want, I'll maximize it a little bit. Yeah, I'll maximize it. Okay, 0b. Okay, so when you say 0b, it's binary. So when you say binary, your number should be made up of 0 and 1s only, not any other digits. You cannot have 2, 3 and all. You got 0 or 1. So I can have a combination of 0, 1. So I can say 1, 0, 1, 1. Okay, so you see this is equivalent to 1 0 1 1 will be 8 plus 2 plus 1 11. So you can see, I'll just say num decimal equivalent will be 11. So you can see here 11. Okay, so I can have 1 1 1 1. So you can see this will be 15. Okay, so see, when you say integer, the integer can be represented in any forms. It may be octal, hexadecimal, binary, or decimal system. Decimal system means by default, when you say num is equal to 20, it is a decimal system. But apart from that, when you want to represent using any other system, radix we call it as radix also, radix 8, radix 16, or radix 2. Then we should be starting with 0b, and accordingly 8 means 0 O means octal, hexadecimal means 0x, binary means 0b. Right? So this is how you represent a number. Okay, this is integer number. And of course, to convert from other form to base system, this actually converts from hexadecimal to decimal, or octal to decimal, or binary to decimal. I want reverse. That means decimal to I want octal. So in that case, we need to go for a function. So I'll just say, look at this. I'll just go here. I'll just say, I want it basically octal. So I'll just say octal of what? Octal of 8 I want. So when you say octal of 8, you will get 1 0. Then you will get 0 O 1 0 you will get. See 0 O 1 0. but this will be in a string format. This will be in a string format. Okay, this will not be in a number format. Okay, because this combination of the 0, O, 1, 0, they cannot be represented as a number because it's a mixed type. See, O means it's letter. Okay, 0, 1, 0, they are digits. So it will be only of type string. So this is octal of 8. Okay, fine. Suppose if I say hexadecimal. Okay, hex of I want F. Okay, hexadecimal of F. So not hexadecimal, sorry, hexadecimal of 15 will be F. So you can see here. Okay, 0xf. Look at hexadecimal of 15 will be 0xf. Okay, so you can see here, similar to octal, we get 0xf actually. Okay, so any number you give, you will get in hexadecimal. So see, the OCD function converts, okay, a decimal number into octal number. Okay, octal representation, string representation. Then hex function will convert a decimal into hexadecimal string representation. Suppose if I say 15, so I'll just say 30. Okay, so we'll just see what is the hexadecimal representation. Look at this, 0x 1e. How it is 1e? See, e into 16 power 0 plus 1 into 16 power 1. Okay, that is how it works. You see, I'll just put a comment here. So how do you get the output now? See, you let us take 1 into 16 power. Okay, basically power means we put this way, 1 plus, okay, e means actually when you say e 14, so 14 into 16 power 0. Okay, so 16 power 0 will be 1. So 14 into 1 will be 14, and you say 16 power 1 will be 16. So 16 plus 14 will be 30. Hope it's clear. It's clear. Okay, fine. So you see, when you say hexadecimal system, you have to convert the number into, see, this is how it works. So 30 was converted into hexadecimal format. So how we got this output? Okay, so you see, look at this example. I'll just show you that example. How we got 1 0. 1 0 means it's 8 actually. So when you say 1 into 8 power 1 plus 0 into 8 power 0. So this term becomes 0. Yes, plus 1 into 8 power 1 is 8. So that's why you got 8 as well. 8 as well. Okay, hope it conveys the information. Okay, so OCT, hexa, and binary. So if you look at one more function, that's called binary of. So you put some decimals, 15. So you'll get 0b 1111, 4 ones. Okay, 0b 111. Okay, it's nothing but how do you decipher it? You see, 1 into 2 power 3 plus 1 into 2 power 2 plus 1 into 2 power 1 plus 1 into 2 power 0. 2 power 0. Okay, fine. So you see, 2 power 3 is 8. 8 plus 4, 12. 12 plus 2, 14. 14 plus 1. 2 power 0 is 1. 15. You got 15. Okay, so these are you convert between a decimal to other system, but the output will always be a string representation. Okay, fine. So hope it conveys the message. Okay, then we have represented, and floating point numbers. When you say floating point numbers, you can represent like this. The floating point number will be represented in Python. Okay, for example, age will not be floating point number. I'll just say height. Height is equal to 12.89. Okay, I'll just say height, see 12.89. Okay, so type will be float. So if I say type of is a function. It's a float. Fine. And one more beauty of Python is, see, integer, there is no integer, short integer, long integer, int. See, a lot of confusion in other languages. For example, if you take C, C++, Java and all, you get a lot of but here a single integer data type can hold any number of any size. For example, I'll just say currency, or you can say population. Population is equal to, I'll just put such a big number, you can see here. Okay, I'll just say pop. You can see here, any big number can be represented using integer. The integer is flexible enough to hold any small or any big numbers. Okay, fine. So you see, I'll just put type of Papu. You can see int. It's int only. It's not long integer or something else. It's only integer. Okay, that's beauty of Python. Okay, so Python gives you a lot of scope for handling numbers. Fine. Of course, they will be converted from different types of numbers into integer, any kind of things, conversions we see. Okay, so I think that was okay. Yeah, and if you go to operators, operators, integer division especially is very important. So when you say integer division, you have true division, floating point division. So what is true division? Suppose if I say 10 divided by 3, so that will give you true division. True division means the output will be floating point number. You can see here 3.333. Okay. Suppose if I say I want floor division. Floor division means the a number which is less than an integer number which is less than the true division result. Suppose I think I'll make it clear this way. If I say 10 /3, that will give me 3 as answer. Look at this 3. This is called floor division. Okay, it gives me an integer which is less than true division answer. Okay, fine. So this is called true division. True division. Of course, floor division. Okay, and of course, then we have other operators also. Arithmetic, plus, minus, multiplication, division. Are all they're all same as C++ and other languages. No, not much difference actually. Not much difference. Okay, fine. So I hope this session was useful. Okay, we'll continue in the next session. Thank you.